Right, so we have another colligative property, again, a property that just depends on the number of solute particles that are dissolved, and this one is osmotic pressure. So again, it's a colligative property. Which only depends on the amount of solute particles dissolved. And if you're wondering, why does the boiling point cause elevation? Why is the freezing point depressed? Why is there osmotic pressure? We're not going to cover that in this course. It's all based on a concept called entropy, which is a pretty kind of difficult concept to get your head around. If you take Chemistry 102 here at MSJC, you'll learn about entropy. Or maybe, your physics class, all kinds of other classes. But for now, we're just going to say this stuff happens because of entropy. We're not going to focus a lot on osmotic pressure. I just want to introduce the topic. So in osmotic pressure, we have some kind of semi-permeable membrane. So this membrane allows our solute particles to go through it, but not our, or my bad, other way around. It allows the water to go through it, but not the solute particles. So you can see the solute particles stay inside of this semi-permeable membrane. And what's happening is water is going into the solution, right? You see here, there's no water, and now there is water. And so it's always going to do this in order to dilute the solution. So water will flow to dilute a more concentrated solution. Right, so it's acting to dilute it. Right here, we've got a lot of particles in a little bit of water, and now we have the same number of particles in more water, so we've become more dilute. And so the osmotic pressure is basically the pressure caused by this process. We're not going to talk about it too much. We just want to bring it up due to its application in medicine. So in medicine, right, a lot of times you have to give patients IVs. And when you give them an IV, it's always a saline solution or a salt solution, right? It's got salts in there. If you gave them a pure water solution, they would die. And the reason is that IVs need to match or approximately match the solute concentration of the blood. If they don't match it, we're going to have some kind of osmotic pressure. And there's two things that can happen with this osmotic pressure. In a hypertonic solution, our outside is more salty. So the solution that we're putting the blood in is more concentrated. And so the water is going to leave the blood cells, and it's in order to help dilute the solution. And so then your blood cells get shriveled up. And if they get shriveled up too far, they die. In an isotonic solution, our concentration of solute in the blood cell and in the solution that we're placing it in is the same. And so we have water going in and out, but no net change. And so your cell is totally fine. In a hypotonic solution, our solution is less salty or less concentrated. And again, the solution that we're talking about here is the solution that the blood cells are going into. And so since the solution is less concentrated, water is going to want to go inside of the cell to help dilute the salt concentration inside the cell. Well, it'll fill up like a balloon. And if you fill up a balloon with too much water, eventually it's going to rupture and your cell will die. So there's just a cool application of colligative properties in medicine.